Welcome again. This is sample exam questions 002 for the AQA Level 2 Further Maths course. We've got 3 questions to answer. Question 1. A quadratic curve has equation y is equal to x to the power 4 minus 4x squared plus 10. A. Work out dy dx. B. Find the equation of the tangent to the curve at a point where x is equal to 2. Give your answer in the form y is equal to mx plus c. So for A, y is equal to x to the power 4 minus 4x squared plus 10. So dy dx will be equal to this 4 comes down to multiply, you get 4x, and then we raise the x to the power 4 minus 1, that's 3. So the next one will be minus 4 times 2. The 2 comes to multiply the 4. This 2 comes to multiply the 4. You get minus 8. And the x will be raised to the power 2 minus 1, which is x. Here it's a constant, so we get 0. So for A, dy dx is equal to 4x cubed minus 8x. For B, we need to find the gradient of the tangent to the curve at a point where x equals to 2. So we substitute x equals to 2 into dy dx, which is the gradient function at any point on the curve. So when x is equal to 2, dy dx is equals to 16. So this is the required gradient of the tangent. But we need to find the coordinates of that point where x equals to 2. We know the x coordinate, so we can find the y coordinate by substituting 2 into this equation. So if we do that, we are going to get y is equal to 10. We now have a point that passes, the curve passes through, and also the tangent passes through. So we can now go and write the equation as y minus 10 over x minus 2 is equal to 16. Because if you have, let's say the tangent is this, and you have a point here, which is x, y, and a point here, which is 2, 10. And then we drop a line here and drop another line here. That is 90. So the gradient will be this length here, which will be y minus 10 over this length here, because the gradient is rise over run. But we know that that is equal to 16. You can rearrange to get y minus 10 is equal to 16 brackets x minus 2. Expand the brackets to get y minus 10 is equal to 16x minus 32. And then finally you get y is equal to 16x minus 22, which is in this form. So here the m is 16 and the c is minus 22. Question 2. Work out all the solutions for x and y if this matrix here times this vector is equal to this vector. So we multiply out and we get this. X times x is x squared, minus 4 times minus 5 is 20. So x minus 4, 6y multiplied by x minus 5, you're going to get x times x is x squared, then minus 4 times minus 5 is plus 20. Then 6 times x is 6x. Then y times minus 5 is minus 5y. So that is your vector when you multiply this matrix by this vector. And so we get that. But we know that this must be equal to 9x and 9. So we equate them. So it means that for the top row, we are going to get x squared plus 20 is equal to 9x. Rearrange to get x squared minus 9x plus 20. Factorize to get x minus 5 and x minus 4. We can solve to get x equals to 4 and x equals to 5. So these are the two values of x, the two possible values of x. But we also know that 6x minus 5y is equal to 9. So now we can substitute the values of 4 and 5 into this equation to get the values for y. So let's do for 4. We're going to get 6 times 4 minus 5y is equal to 9. And then 24 minus 5y is equal to 9. And 5y equals to 24 minus 9. That implies that y is equal to 3. Do the same thing for x equals to 4. Should be x equals to 5 here. So when we do that, we're going to get 6 times 5 minus 5y is equal to 9. That's 30 minus 5y equals to 9. And then we have 5y is equals to 30 minus 9. And then we have y is equals to 21 over 5. So these are the possible values of x and y. Question 3. Solve this equation. Do not use trial and improvement. So the first thing we do here is find the common denominator of x plus 1 and x minus 3. That will be x plus 1, x minus 3. So I'm going to multiply each term, this term, that term, and 5 by this common denominator. So I get something like this. And the reason why we do that is this. You can see that immediately this will cancel that. This will cancel this. And so we get an equation without fractions in this form. 5 times x minus 3, which is here, plus 4 times x plus 1, which is this one here, and then 5 times x minus 3 times x plus 1, which is there. So if you expand, we are going to get 5x minus 15 plus 4x plus 4 is equal to 5. And then you expand this one, you're going to get x squared plus x minus 2 minus 3x minus 3. We need to simplify what is in this bracket to get this. So here, what we've done is 5x plus 4x is 9x, minus 15 plus 4 is minus 11. And then we simplify what is in the bracket because x minus 3x is minus 2. We can now expand the brackets to get 9x minus 11 is equal to 5x squared minus 10x minus 15. We can rearrange this equation by taking 9x and minus 11 to that side. So we are going to get 5x minus 10, and because this is coming over, it's going to be minus 9x, then plus minus your 15, and then because this is minus, it becomes plus here, and so we get that. Let's simplify that. We're going to get 5x squared minus 19x minus 4 is equal to 0. So now we need to factorize this quadratic equation. We do that by multiplying the coefficient of the x squared by the constant term, which is minus 4, to get minus 20. We need now to break minus 20 down into two factors that will add to give us minus 19. And it's going to be minus 20 and 1. So we now replace minus 9x by minus 20 and then plus 1, which will give 5x squared minus 20x plus 1x, but we write x minus 4 equals to 0. Looking at these two terms here, it's a common factor. That common factor is 5x. That will be factorized out. And looking here, we have a common factor. That common factor is 1. So we can factorize that one out as well. And we are going to get 5x brackets x minus 4. Therefore, this side we have 1 brackets x minus 4. So we now have two terms. This term here and that term. And the common factor here is x minus 4. So we can factorize that one out to get x minus 4 brackets 5x plus 1 equals to 0. So we can now solve this to get x minus 4 equals to 0 and 5x plus 1 equals to 0. That means x equals to 4 for this side and x is equals to minus 1 over 5 for that side. And this is the end of this session of sample examination questions for AQA Federal Maths. Thank you for watching, and I'll see you in the next video.